Alright, now that you have completed your data and hopefully you have created a graph to represent your measurements, okay, and you should have had kilograms as what you varied and newtons as what you observed, and hopefully your data looks like this. Bigger kilograms gave you bigger newtons. Okay, so let's label this as force measured in newtons, and this is mass measured in kilograms. And you should get a nice straight line there. We could even make a best fit straight line. Remember, best fit straight line goes through most of your data points. Now, just like before, if y equals mx plus b from math class, the equation for a line, then our force is equal to, now I'm going to use the word slope here. The slope, because x is the mass, and I'm going to leave it as a little m, so I'm not trying to be confusing. And hopefully you've got a y-intercept that's really close to 0, so hopefully b is approximately 0. Okay? Now with your calculator, you should be able to set up a linear regression of this data, and hopefully your slope value, and just to remind you, slope is rise over run, so in this case it would be the change in the force, because that's on the y-axis, over the change in the mass, and hopefully you get a number that's about 10. Now that is a very special number, and that's how we're going to define what weight is. So this force that was acting up, okay, on our mass, we had a spring force that was up, your hanging mass, and then a gravitational force that's down. So the spring force that you just measured was equal to about 10 times your mass, or the mass that was hanging. And if I look at this diagram right here, the object wasn't moving. It was all balanced. It was in what we call equilibrium. So you have balanced forces, equilibrium. That means that the sum of the forces is 0. That is Newton's first law of motion. Now let's get back to what this means. So that means that when I sum up that spring force that was up, so I'll have up be positive, plus, but the gravitational force was down, so I'll make it negative, that should be equal to 0. Now, do some magic algebra here. Your spring force should be equal to the gravitational force. Your spring force from way up here, I'll go back up here, your spring force was 10 times m. So it was about 10 times the mass is equal to the gravitational force. So this guy right here, this 10, is a constant. It is the gravitational constant. Sure does look like the acceleration due to gravity. So the gravitational force is, we usually put the g second, so m for the mass times g, mg. This is the gravitational force. It also has another name. It's also the weight.